You know that feeling when you're lying in bed, everything is perfectly quiet, you're just drifting off, and then suddenly, bam, your entire body slams awake like you just missed a step on a staircase? Well, you are definitely not alone. In fact, that sudden falling sensation is something that roughly 70% of people experience at some point. It's really just one of the many ways our highly advanced biological computers, our brains, stutter and misfire during their nightly shutdown and boot-up sequences.
Welcome to today's Explainer. We're diving into this incredibly fascinating look at the brain's sleep glitches. We're going to explore the strange, occasionally terrifying, but mostly totally harmless neurobiological misfires that happen while we're sleeping. So if you've ever wondered why your brain occasionally acts like a computer with a corrupted hard drive at 3 in the morning, you are absolutely in the right place.
To make sense of all this, we're going to take a chronological journey through a single night's sleep. We'll kick things off with Phase 1, powering down. Then plunge into Phase 2, the depths, and then cover Phase 3, booting up in the morning. After that, we'll check out Phase 4, system overload, and finally end on a really fun note with Phase 5, admin access.
All right, let's start right at the beginning of the night with Phase 1, powering down. This is that weird transitional period where your brain is shifting from active wakefulness into sleep, and occasionally, it just completely scrambles the signals.
These shutdown glitches are incredibly common. That falling sensation we just talked about, that's technically called a hypnic jerk. You see, as your muscles relax for sleep, your powering down brain sometimes misreads that sudden loss of muscle tone as you literally falling, so it fires a jolt of electricity to catch you. Researchers actually think this is an evolutionary leftover from when our ancient ancestors slept in trees, where a sudden drop in muscle tension literally meant you were about to fall out. We also have hypnagogic hallucinations, which again affect about 70% of us. As your brain starts firing up dream activity while your conscious mind is still partially online, visual or auditory signals basically bleed through. You might see random flashes of light or distinctly hear someone call your name.
And then there's exploding head syndrome, which hits about 10% of people. Picture this, you're almost asleep, and an enormous crash or explosion goes off entirely inside your skull. I know, despite the terrifying name, there's absolutely no physical event happening. It's just a massive neurons firing all at once. Normally, your brain quiets sensory processing really gradually, but sometimes it misfires, and a bunch of auditory neurons discharge simultaneously. So it's completely harmless. It's honestly just your brain's auditory processing failing to use the fade-out button.
Let's see how this builds as we enter Phase 2, the depths. This is the middle of the night. Your conscious brain is mostly offline, but your physical hardware occasionally decides to switch itself on anyway. Now, it is absolutely crucial to understand the stark difference between a nightmare and a night terror, because they are not the same thing. A nightmare happens during REM sleep, you wake up, you remember it clearly, and you feel conscious fear. A night terror, on the other hand, happens in deep, slow-wave sleep. A person might sit bolt upright, screaming, with a heart rate of 180 beats per minute in complete physiological panic. But the crazy part, they are entirely unconscious. You can't comfort them normally, and actually, trying to hold or restrain someone during a night terror can make the episode way worse. And in the morning, they will remember absolutely nothing.
Another classic glitch from the depths of sleep is sleep talking, which affects around 66% of people at some point in their lives. People always wonder, can you extract juicy secrets from a sleep talker? Well, sorry to disappoint, but the answer is almost never. The brain isn't running some sort of conscious monologue. It's just producing meaningless verbal fragments from networks that are only partially active. It's really just your brain accidentally leaving its microphone on.
Now, there is a massive misconception out there that sleepwalkers are physically acting out their dreams. They aren't. Dream enactment actually happens in REM sleep. But sleepwalking? That happens in deep, slow-wave sleep, where dreaming is pretty minimal. Your brain simply activates purposeful movement, like walking around, unlocking doors, maybe even making a sandwich, without any conscious awareness or dream narrative attached to it whatsoever.
Eventually, the night ends, which brings us to Phase 3, booting up. Your alarm starts ringing, but unfortunately, your brain's hardware is sometimes severely lagging behind the real world.
If you have ever felt completely, utterly useless for the first 30 minutes after your alarm goes off, you are experiencing sleep inertia. Waking up is not an instant process, guys. The chemical adenosine, which is what drives sleepiness, hasn't fully cleared out yet, and your prefrontal cortex, the part of your brain that handles rational thought, is literally still offline. This window is so cognitively impairing that pilots have crashed planes and surgeons have made terrible medical decisions during it. So if you make a really bad choice first thing in the morning, hey, your brain might literally still be asleep.
Okay, before we look at our next set of waking glitches, we need to quickly define REM atonia. This is the biological mechanism that safely paralyzes your muscles while you dream, and it's a super necessary feature, right? Otherwise, you'd jump straight out of bed while dreaming about running a marathon. But when this mechanism accidentally overlaps with your waking consciousness, things get genuinely terrifying.
So, as you can see here, when REM atonia persists after you've woken up, you get sleep paralysis. You are fully awake, but your body hasn't unlocked yet. And because you're paralyzed, your brain's threat detection system absolutely panics and hallucinates a scary presence in the room, like a shadow person. Next up, we have false awakenings, which happen during REM sleep. Your brain basically runs such a convincing, high-definition simulation of your morning routine that you genuinely believe you've woken up and started your day. Sometimes you'll loop through this multiple times before you actually wake up. And finally, confusional arousals happen when you're abruptly pulled out of deep sleep. You might appear awake to someone else, but you have zero idea where you are or what's going on, and you're operating with severe cognitive impairment.
Now, let's hit pause on our chronological night for a second and look at Phase 4, System Overload. What actually happens when you deprive yourself and skip your brain's required maintenance cycle?
17 hours. That is an incredibly startling number when you think about it. It's really just a regular, long day awake. But studies on sleep-deprived individuals show that after just 17 hours without sleep, the brain starts stepping in and forcing dangerous, involuntary shutdowns.
These forced shutdowns are called microsleeps. For anywhere from 2 to 30 seconds, your brain just goes completely offline. You might be sitting upright, your eyes might even be wide open, but internally, consciousness has totally vanished. And the scariest part is that you cannot detect your own microsleeps because, well, by definition, you are unconscious. This makes them unbelievably devastating, especially if you're behind the wheel of a car. You don't even realize you're impaired. You're just suddenly 2 seconds further down the highway with absolutely no memory of the gap.
And when you finally do get to sleep after a long period of deprivation, you hit what's known as REM rebound. When your REM sleep gets suppressed, whether that's from accumulated sleep debt or even substances like alcohol, your brain actually keeps a ledger. The second it gets a chance, it aggressively catches up, plunging you into dramatically longer, weirder, and way more emotionally intense dreams. It's a crystal clear signal that your brain is acting like a debt collector, cashing in on its missing sleep.
All right, let's move past the terrifying glitches and end on a much more empowering, fun note with Phase 5, admin access. Because this is the one brain glitch literally everyone actually wants to experience. I'm talking, of course, about lucid dreaming. This is that magical state where your brain is simultaneously in REM sleep, dreaming, and yet completely aware of the fact that it is dreaming. I know it sounds like straight-up science fiction, but it's totally scientifically confirmed. Researchers actually had participants move their eyes in specific, pre-agreed patterns once they became self-aware in a dream. And those eye movements, which happen to be one of the very few things not paralyzed by REM atonia, showed up perfectly on the EEG monitors. Roughly 55% of people report experiencing this verified state at least once.
And the absolute best part? You can actually train yourself to intentionally trigger this glitch and gain admin access to your own dreams using a few established techniques. Number 1 is reality testing. Basically, routinely checking your hands or reading text while you're awake with the hope that the habit carries over into the dream world. Number 2 is wake back to bed, where you sleep, wake up briefly in the early morning, and then go straight back to sleep to drop directly into REM. And number 3 is the mild technique, which is setting a strict, focused mental intention to recognize that you are dreaming right as you fall asleep.
So, from the totally harmless jolt of a hypnic jerk all the way to the terrifying presence of sleep paralysis, our brains are just incredibly complex machines that occasionally stumble in the dark. But honestly, understanding these neurobiological misfires makes them so much more fascinating than they are scary. So I'll leave you with this one thought to ponder. Tonight, when your brain powers down and begins its nightly sequence, which glitch are you going to experience?